in the week 4, we had discussed about what is the extreme value distribution, what are their types of extreme value distribution, how we can fit that distribution to the model data set, how we can estimate the parameters of the extreme value distribution, and then based on fitted distribution how we can assess the let us say probability of occurrence of different extreme events and their corresponding magnitudes. And why it is important? Because when we know about the magnitude of different return period or return level, we would be able to give a more insight about what is the frequency of occurrence of certain different events in a particular region, so that we can manage the infrastructure, public health, and lots of different socioeconomic parameters for mitigation or vulnerability assessment. So, in the week 3 we had already covered how we can use historical data set and how we can use download the climate data or historical observations data set. So, in the last week or week 3 we had already discussed about how we can use different types of available resources, particularly the tool which was developed by IT Mandi, where we can use any point information in different parts of the country and can get an information about what is the historical rainfall amount. Okay. So, basically we have already covered this, and then basically we can get an idea about what is the rainfall, or let us say we can get an information about this is the rainfall data, but we can also get an idea about what is the maximum rainfall in a one particular day, what is the minimum rainfall, what is the maximum temperature, like that. So, if this is the data set we can download, how we can in this example, in the last assignment we have talked about how we can fit the extreme value distribution and we can assess different return periods. For this assessment we can go to, I will demonstrate how we can use it for, let us say, using MATLAB software. You can also replicate this analysis using R or Python, because the coding is slightly changed, but overall the procedure will be very similar. So, this is basically we can you can use the these programming languages and can basically download or analyze the GEV or GPT distributions. So, basically Hridesh, अच्छा यहाँ भूल गए थे क्या? अच्छा यहाँ एचओडी ने साइन नहीं किया क्या?
नहीं वो प्रॉब्लम नहीं, वो तो पीआई का लगता है, एचओडी का तो इंस्टीट्यूट प्रोजेक्ट होता तब लगता है। आपका नंबर हमारे पास
0297 नेम।
अरे नहीं दीजिए सर, नहीं
तो लिखा है। थैंक यू हरदेश। So, we can use the online MATLAB like these tools, or maybe you can use R programming or Python programming to fit the extreme value distributions. So, I'll give you a very brief overview about how we can use it. So, suppose you can load the data. So, this is the MATLAB platform. You can load the data, upload file here, and you can get the file in the form of, let us say, CSV or Excel or text file like that, and you can load the data of your, let us say, extreme rainfall, extreme temperature, extreme flow, like that. So, here I have loaded the precipitation extreme historical data set for one particular locations. So, this is basically is stored in CSV file. First I have to extract this data set in sort of MATLAB variable. So, I will write data is equal to CSV read, and then the file name, which is the file name is prcp underscore hist.csv. So, this way we will be able to store the data of rainfall extreme of one particular location. Now, you can, if you can double click here, you will get the data set. So, this is how the data set is looks like. It has around 36 values and all are different extreme rainfall. Now, if you wanted to graphically represent this data set, you can write the command plot, and you can write here data, and when you write here data and then you click, you will get that a plot of the data set which you are using. One minute. So, anyways, this plot is not coming here in this platform, but maybe you can use this command plot data, and then you are able to plot the data of that extreme rainfall which you are using for that particular analysis. So, these are the data set which we are using for GEV analysis. Let us suppose we want to try the GEV, fitting the GEV in this data set. What we can do? We can use inbuilt command which is called let us say so we have in the lecture we have discussed about when we are selecting a GEV distribution, the first and important step is to estimate the parameter. So, generally we estimate the parameter using the maximum likelihood estimation method. So, here we will use the parameter. So, let us say I am write PARAM. Okay. So, here parameters is equal to, let us say I am writing command name is let us say GEV fit, and then we have entering it the data set here. So, this will basically give you the exact parameter values for our GEV fit. So, you can see it here, all the parameters are positive, which means shape parameter is your positive. So, first parameter is called your shape. Shape is equal to your parameter first, that is 0.1344. That is means this data set has a positive shape. Then we can basically calculate, we can store what is the scale parameter of this distribution, which is the second parameter of your GEV distribution, that is called PARAMS and 2. And then you can also have location parameter, that is called location of PARAMS 3. So, here you have already stored the parameter values shape, scale and location. When shape is more than 0 or positive number, it is a kind of a Fréchet distribution or heavy tailed distributions. So, using these parameter values, we will be able to calculate what is the the correct GEV distribution for this particular data set. By using these calculated GEV data set, we will be able to calculate what is the written period of different probabilities or different probabilities written periods like that. So, how we can do that? So, we have already quantified the parameters of this GEV distributions. We have to define which written periods we are interested in. So, let us say we are defining written periods is equal to 2, 5, 10 and 100, let us say. So, these are the 4 written periods I am interested in. So, what I can do? We can write a formula which is basically so here basically we can find out this formula is, so written levels of GEV is equal to, we can write location, which is the location parameter of our GEV data set, then is scale is divided by shape. Then in the MATLAB we write dot with the star for multiplication. Then we can write here the correct formulation for GEV written period estimation is, within the bracket we write minus log 1 minus 1 dot divided by your written periods, which we have already mentioned, then your shape of parameter, and then minus 1, the bracket will be closed and here you will write semicolon. So, this is basically it is calculating the written levels based on the given written periods values, which means if you write here written levels GEV and press enter here, you will get these different numbers values, which is 63.65 mm for 2-year written period, then 92.5937 mm for 5-year written period, then 114.3309 mm for 10-year written period, and 198.4783 for 100-year written period. So, in the last lecture we talked about, when we are talking about GEV distribution, GEV is generally based on the block maxima approach, where we are selecting the annual maximum values for different events, and that is basically we use for GEV analysis, and then we do all sort of parameter estimation and written level estimations like that. We can also do similar type of analysis for let us say GPD distribution, general Pareto distribution. So, before one more thing is important. Let us suppose we have already quantified the parameter, we need to know that whether the GEV data set or GEV distribution which we are using it is correctly representing the data set or not. So, that you can check using the QQ plot or quantile plot assessment. So, quantile plot assessment is very simple. So, basically we can basically compare the empirical quantiles which are coming from your data only with your theoretical quantiles which are coming from your probability distribution functions only. So, when you are comparing the empirical distribution, empirical quantiles from data and the theoretical quantiles from the probability distribution function, you will be able to compare whether your fit is actually is falling on 1:1 line or not. So, basically we can calculate P empirical, which is the empirical probabilities, P empirical is equal to, let us say I am saying before this P empirical we can write what is the length of the data. So, n is equal to length GTH. What is the data? Data is data, here is variable name. This is basically the length. Okay. Now, we can calculate the probability of empirical data set, that is, before this we have to, okay, probability of empirical data set, which is 1:n divided by n plus 1. So, this is how basically we are calculating the probability of occurrence of different events. So, when we are calculating the probabilities, we have to also sort our data set from increasing order or decreasing order, like that. So, basically let us say we can call this variable x sorted, where we are sorting the data, let us say that is data. I am sorry, here it should not be caps lock, like that. Now, if you open this x sorted data, you will get that the values are arranged in the decreasing to the increasing order, where we have the last value is the maximum value and the first value is the lowest values, like that. Then using this x sorted, we can basically calculate what is the theoretical quantiles first, and then what is the empirical quantiles of the data set. So, theoretical quantiles and the empirical quantiles can be calculated by theoretical quantiles is theoretical, let us say quantiles, 1 minute, theoretical quantiles of GEV is equal to, so we have fitted the GEV distribution, therefore, we have to use inverse GEV to get the actual values of your quantiles. P empirical, then what is the shape parameter, then what is the scale parameter, and then what is your location parameter. If you just write this, so that you will get the theoretical quantiles of GEV. Now, you can compare theoretical quantiles of GEV and theoretical quantiles of GEV. Based on that, we would be able to calculate what is the empirical quantiles and what is their theoretical quantiles, and we can compare it together to calculate whether your data sets are actually fitting with the GEV distributions or not. So, this is how basically we can check the whether your GEV distributions are following the correct the nature of the data set which we are using it. Now, I will also demonstrate one more example, which is basically the GPD distributions based. The GPD distributions, in the previous class we have already discussed that it is basically used for when we know that there is some sort of thresholds. Okay. So, let us define some thresholds. Let us say, let us see the data set again. So, in this data set you see that the values are like 46, 33, 53, 30, 30, 69. So, let us take 40 as a threshold. Okay. So, I am assuming threshold is equal to 40 mm. Okay. Now, I have to sort what is the threshold here. So, basically we can calculate what is the exceedance of from above thresholds. So, exceedance is equal to, let us say this is our data is greater than your threshold minus or, so where we have crossing this particular thresholds. So, these are the values. Out of 36, 31 values are more than 40. So, here we have quantified those values, all these values are above 40, and we have taken it out in separate variable. Now, we can use similar analysis like what we have done in the GEV case. We can analyze the parameters. So, one parameter is threshold, which we have already set. Another parameter is a shape parameter of GPD, which is we can calculate. So, first we have to calculate the parameters of, let us say, GPD distribution, and this is basically we can calculate by GP fit, and that is basically here we will take exceedance instead of data set, because we have already installed the we have already used the threshold here. So, it has some sort of warning, but it has basically fitted the data. So, you can basically parameters of GPD. So, we can, if we can look at what is the shape parameter of this. Shape is equal to, the variable name is PAR AAMS GPT 1. So, that is minus 0.6813, and then you can also check the scale parameter here, scale parameter, and it will show you the values is around 124.31. So, this is the shape and scale parameter we have already used, and based on this shape and scale we can further quantify the return periods based on different return levels based on different return periods values like that. So, this is a one example which tells you about these are the examples which using your observed extreme rainfall, extreme temperature or extreme flow conditions, we can fit the extreme value theory model, either GEV data or GPD distributions to the data set, and then using the inbuilt function of MATLAB or R or Python, you can basically calculate what is the return magnitudes at different probability or return period levels, and using this information we can do some sort of more advanced hydrological or hydroclimatic analysis of particular regions like that. So, this is all about the solution of assignment 4 of week 4 in the so this is what I hope you are able to understand how we can proceed with this particular example. Thank you so much for listening.